given the importance of the topic of the workshop, I decided to summarize some of our work on grounding response generation in conversational systems on structured and unstructured knowledge. I chose to talk about a few papers, but all of these are joint work with a large group of people who I'm thankful to. Okay, so basically, like it's after ACL, we have seen a ton of new papers, lots of exciting new work, but we have seen, and I keep seeing that due to the large language models, there has been tremendous progress in natural language processing tasks. We have all started after that for some time looking into how do we train these models for the specific task so that they perform better? How do we pre-train? How do we fine-tune or other approaches like that are more efficient in terms of data and parameters like priming, prompting, adapters, and so on. But at the same time, we have also, in addition to the benefits, we have also started realizing there are certain challenges that were existing or that are new. For example, these large language models, especially when you use them for generation, they do capture, they do generalize, so they do hallucinate incorrect things, which could be quite dangerous in the situation of conversational interactions. To just give the wrong information to the users and pretend, like we have seen, each of us has seen many examples of this, and to pretend that these are actually accurate. Bias is yet another problem. These large language models do capture the bias inherent in the data, can generate things that are inappropriate, which could be very damaging for the conversational systems. We have seen cases where the responses do not really make sense in terms of common sense. So one solution that we have in each of these areas is grounding the response generation, using the large language models to capture some of the knowledge, the specifics of the language, but grounding the responses also on knowledge from structured or unstructured knowledge sources. Unstructured, I use that to refer to basically textual sources. So I decided to summarize 3 recent papers. So they're recent. I mean, my presentations probably are not too polished on them. So the first one is related to task-oriented conversations where we do have APIs, but we would like to bring in knowledge from the web. Second one is for open domain conversations, and we deep dive into the knowledge selection problem for open domain conversations. And the third one is basically common sense and integration of that in response generation. And I'll start with the first one. This work is basically based on the dialogue state technology challenges that we have been organizing last year and also this summer. So basically, when it comes to conversations, there are 2 types of works that have been prominent: open domain social conversations and task-oriented conversations. On open domain side, the focus is naturalness and relevance. Usually knowledge is integrated from free-form sources or structured sources to have a knowledgeable interaction in addition to an engaging one. On the task-oriented side, the work has been split in these 2 mostly because on the task-oriented side, usually there's an API that provides some information to the system for task completion and enables actually the task completion. Here, the task success is important, and the information is dynamic. It could be changing. That's why we do need these backend APIs. So this is on the scientist's mind, on the researcher's mind, or on the engineer's mind. When it comes to user, they don't really know if it is an open domain, like what can the system do really? So they can ask different types of questions to each side. That has been driving some of my research lately. how do we not break the conversation flow and then use other sources? So currently, for example, if you interact with a task-oriented dialogue system that has access to an API, let's say in the it's an example from the multi-voice corpus, but it could apply in the real world situation as well, where there's a backend API to accomplish the task. In this case, the task is booking a train. So if the user says something, because users do not exactly know what the API can handle or not, and then they may have requests, side requests that are important for task completion. So for example, imagine a person, they want to bring their dog to the train, and it's important for them to know if dogs are allowed, because if not, maybe they will take a cab or use another form of transportation. So current systems, task-oriented systems respond saying, sorry, I don't know about that. Then the user goes to web. This is a loss for the dialogue system, because then the user can accomplish everything on the internet using other sources, which is not ideal for them either. But there's a lot of information on the web about these type of things. So our goal has been basically bringing the information, unstructured information on the web to the task-oriented conversations, and be able to respond, switch from the API to the web resources, to be able to respond to the user to say that, yes, you can bring your pet, and then there are some conditions. For this type of approaches, for this type of systems, there are multiple issues or challenges. First of all, users want to accomplish the task, so the goal is to still to accomplish the task, but they can switch back and forth from API focused things to the general web things, and they don't really need to know that the system is actually using these two different sources, although it may be good to acknowledge where you get the information from. And another important thing is the system shouldn't lose track of the state, the task state, dialogue state during these transitions. So we did collect a set of data, and then we augmented the available data out there to be able to study this form of transitioning back and forth from API to the open domain knowledgeable interactions. For new data, we have collected some data following the multi-voice collection, but integrating these knowledge-seeking turns into the conversations. And part of our data is written, part of it is spoken, so that we can actually see the differences between the spoken and written genre, and there are big differences. Plus, we can also study issues related to robustness to speech recognition error. And we have been organizing these two challenges, as I mentioned, for the past 2 years. On the integrating the knowledge into the conversation side, that was the main focus for the STC9. We have defined 3 tasks. How do we detect when the users are talking about something that is not in the walled garden of the API? Then once we detect that, how do we select knowledge that could answer the user's request, that would help the user's request? And then finally, how do we generate the next turn using the knowledge that we gathered from the web, but also being consistent to the flow of the conversation, being consistent to what the user and the system has discussed before. And this was for last year's challenge. This year's challenge, we are actually looking at the overall system and dialogue state tracking as well. So basically, we treat knowledge-seeking turn detection as a binary classification task. So the users come and say something. At each point, we try to classify them, whether this could be answerable from using the API, or this could require some knowledge lookup on the web. And for knowledge selection, we treated this as a ranking problem. You can retrieve a set of documents that are associated with the conversation context, and then try to mark them as relevant or irrelevant for the conversation. Once the relevant knowledge is determined, then the next step is basically integrating that into the next response. And we have been using knowledge-grounded response generation for this purpose, we and a bunch of others. So last year's challenge, we had over 100 submissions, 24 teams that have participated. Here I have the word cloud from the system descriptions. You can see the language models pop up. Other things such as ensembling also pop up. A lot of teams, given this is a challenge, a lot of teams also use the ensembling methods. So there is a lot of information in the paper, especially the workshop related one, but related to the results. One of the high level points is we had challenge in figuring out which system is actually the best system. Usually the automated evaluation metrics are good. They helped you to identify the top teams, but we had to rely on manual evaluation. We did perform human evaluation and have seen that, especially looking into the differences between the automated evaluation and human evaluation. We have seen that knowledge selection is actually one of the most important tasks here. Because it was the main determiner of the winning team. None of the automated metrics do help in seeing the nuances between the correct and the incorrect responses. And then human evaluation identified there are these differences, and knowledge selection was the main contributing factor. We have improved our approach since then. At this workshop, few minutes back, presented our improved system, and I suggest like looking at his paper or maybe talking to him during the poster to get more details on how did we improve and then what results do we get since the workshop. But basically, we decided that this is such a challenging area, we should continue work as community in this area. So this year we are focusing on, in addition to the last year's tasks, we are also focusing on dialogue state tracking, which helps with gracefully returning to the tasks. And we are also looking into robustness to speech recognition errors. Here I have 3 pointers for the tracker repo, the overview paper that I referred to in the very beginning, and also information about the next track. So the challenge is ongoing. If you haven't looked at, just please consider. So the second area that I chose to talk about is knowledge selection for open domain conversations. Now we did talk about task-oriented conversations where selection is very important. It's the same for open domain conversations. It's very important to give the users right information during the conversations to earn their trust, to engage them in the conversation and so on. A bunch of us, including our work, has been making assumptions around the fact that, well, you have a conversation context, you could bring a bunch of documents related to conversation context using retrieval, then you could use knowledge selection to identify one of them as the relevant knowledge and then generate a response based on that. However, this assumption of like existence of single relevant knowledge per context has been driving the data collection, has been driving the science, but we do have some concerns about the subjectivity of this task and whether it's right to do it in this way or not, both in terms of the collection, but also evaluation. So we asked this question, are the existing methods regarding the use of data and evaluation flawed or are they appropriate? Luckily, there are a bunch of great corpora out there, Wizard of Wikipedia, CMU, DOG, Topical Chat, and so on. So in this work, we mainly used Wizard of Wikipedia here. The collection was between 2 humans. One of them is the kind of like the user. The other one is the knowledgeable expert. And the data was collected from Turkers. The knowledgeable expert was presented a set of documents, sentences, Wikipedia documents, and then marked the ones that they use in their response and as the sentence that is being used. And afterwards, we have seen a bunch of work that actually try to do this knowledge selection as a single knowledge sentence classification problem. However, when you actually look into the data, and then this applies to other data sets as well, oftentimes there are multiple sentences that are relevant to the given conversation context. So in this example, I do have a specific question. Do you know any famous guitar players, or have a favorite guitarist that you listen to? So coincidentally, Turker chose Eric Clapton, chose to talk about Eric Clapton, but there are alternative relevant knowledge snippets in the corpus, in the data, that could have been used as well. And does it make sense to categorize this as positive, all of the rest as negative examples? No, it doesn't. So we do feel like the choice of one knowledge sentence over the others is a subjective decision that the annotators do perform. Here's another example. Is the subjectivity is not just in questions. So this one was question. We were expecting maybe a more focused content, but even the human can leave the conversation context open-ended. And in this case, the system says I work in an animal shelter. Human says that's great. I salute you for that, and so on. So it's a very open point, and lots of sentences could actually be relevant in this context. And the annotators has chosen one of them subjectively based on what they thought they could form a response, but probably they could have chosen the others to formulate a response equally. So we did actually do a pilot study. We hired 40 experienced annotators, people with linguistics backgrounds who are trained to do annotation. We looked at 20 conversation contexts, and each of these have about 30 knowledge candidates from Wikipedia articles, making up 610 knowledge snippets in total. And this is given to the annotators. We asked them select all the knowledge sentences that could be used to craft a relevant response for the following turn, using the dialogue context to help assess the relevance. And we asked them, as relevant sentence should not change the topic. So try not to diverge from the topic, try to formulate something related to the past conversation. So of these 610 knowledge snippets, 177 were not selected by any annotator. So that part is clear, nobody thinks they are relevant. 7 of them were selected by all the annotators as relevant, and only 1 of them was actually in the golden set that Turker in the original collection annotated. And the goldens of the 20 turns, they were selected only by 77% of the annotators. So we looked into inter-annotator agreement on the overall, on all of these annotations, and also for the goldens. The overall is moderate. On the goldens, we didn't really get good inter-annotator agreement at all. So we thought, maybe this is subjective, but maybe we will get a subset of people who would at least agree on certain categories. So maybe it's not really that subjective. So we did sample 10 annotators 100 times, and then we did compute agreement between each of these subgroups as well. The best agreement that we were able to find was getting close to 0.6, which is still in the moderate, but we basically couldn't find a more agreeing community of annotators amongst these. So given that, so low inter-annotator agreement, it could be an indication of unreliable data. We studied this task, we just trained the annotators and so on, but it could also be the indication that the task is subjective. Driven by this, we thought, can we actually try to pick those sentences, knowledge snippets that are chosen by most people, most annotators, and then use them as the targets for knowledge selection. So for this, we annotated almost 800 dialogue contexts. This time we asked 10 people to annotate these 800 contexts. Each of them had, again, about 30 snippets. And we did determine relevance now by thresholding. So if over 60% of the annotators label a knowledge snippet as relevant, we consider that as the relevant, and it could be used to formulate the next response. And 60% wasn't chosen randomly, it was the third quartile of the vote distribution. And as a result of this, we had on average 8 snippets per turn. There isn't one. There were actually 8 on average. There are 39 which didn't have any relevant knowledge sentences, which is okay because you are not supposed to always rely on knowledge. It can actually be a little bit boring if you always rely on knowledge, ground on knowledge for social conversations. And only 41 of them had one relevant knowledge sentence, and a majority had more than one relevant knowledge snippet. So only a single sentence is just an exception. It's not the norm. We did a ton of experiments, more details in the paper, but one result from human evaluation. So we have generated responses for each context using a chosen knowledge and asked humans to assess the quality of these responses for about 100 examples. The scale is 0 to 2, so they are supposed to, the annotators were asked to mark response on a scale of 0, 1, 2 on appropriateness, engagingness, and informativeness. And we use 2 different types of knowledge. One of them is the original golden knowledge. The other one is the wisdom of crowd. And we have indeed seen, especially in terms of informativeness, we have indeed seen differences when we actually use the knowledge sentences that were chosen by more annotators than the single annotator. We have done some experiments on how can we actually use these multi-annotations for knowledge selection and so on. As I said, the details are in the paper, but these results, in my opinion, show the difficulty and then the difficulty of the task and also difficulty of defining how to formulate this as a task. So the third area that I would like to briefly mention is common sense for response generation. Generating responses that are sensible in terms of common sense. I do have the definition of common sense from the ACL tutorial last year. As you can imagine, this is very important for conversations, for response generation in conversations. There's a lot of work in common sense detection, mostly driven by the challenges, a lot of exciting things. We are mostly interested in conversations. So we looked into whether we can identify common sense in conversations and if response generation benefits from fine-tuning on data that demonstrates more of common sense reasoning. So we looked into, first of all, we looked into the available corpora because these days there are a bunch of corpora that could be useful. And our goal was to filter a subset of conversations that we think that demonstrate common sense knowledge. We basically this is just the beginning of the work. We just used a simple heuristic to filter the larger corpora to find out dialogues that include one common sense related triple from the common sense knowledge graphs. In this work, we have used the concept net, the simplified version by Zhou et al. And we identified nouns, verbs, and adjectives in the conversation. We queried these terms to the common sense knowledge graphs, and then determine if consecutive terms like this one and the next one do include terms that are connected in the common sense knowledge graph with one hop relation. So in this example, we have the triple bed is related to sleepy in concept net. So we do mark this conversation as including common sense reasoning. So when we apply this form of filter, we have seen actually the majority of the corpora that are available, conversational corpora out there, do include such relations in their conversations, even if you just limit it to the following 2 terms. And in addition to these, we also decided to collect some data ourselves, used on the social IQA, which is a large-scale common sense benchmark for social situations. We did benefit from the social IQA data. Social IQA is formulated as a set of context question answer triples. I do have a example here. So we did use the context in social IQA to prime the workers. And we asked them to write a conversation that starts with this context and then demonstrates common sense reactions in their responses. So these conversations were self-dialogues, meaning one crowd worker wrote each of these conversations. And we were able to collect about 25,000 conversations with 6 turns per dialogue on average. And we did apply the same form of filtering, knowledge, common sense knowledge triple filtering. We were able to find 11,000 dialogues out of this 25K that demonstrate such relations. We call this the filtered crowdsourced data. And here are some examples. So Tracy performed her function, their employer gave them a raise. Different crowd workers wrote these different conversations that both demonstrate, well, if you got a raise, it must feel good. This is, you're being rewarded for your hard work because you performed well, or you must be feeling so proud, and so on. And first thing that we tested was whether using these data for fine-tuning GPT-2 in this case, a large language model, would that generate more commonsensical responses? We did look into the automated metrics, perplexity, and also Meteor, Rouge, and BERT score. So DD, ED, and TC are the common sense subsets of the daily dialogue, empathetic dialogue, and the topical chat corpora. The test set is formed by sampling data from all of these data sets. So then you can imagine if you just combine all the data sets, your perplexity drops on the test set, and then adding more data, but commonsensical data helps. But the automated evaluation metrics, in my opinion, do not really tell you much. So we also looked into human evaluation, again using the same data sets. We asked Turkers to assess, actually expert annotators in this case, to assess if the response demonstrates common sense or not on a scale of 1 to 10. And we evaluated 300 responses with each of these different models, as well as the human responses. And we have seen that if we do use the crowdsourced, filtered crowdsourced data, and also the other corpora, and then use them to fine-tune GPT-2, we do get higher scores from the human evaluation in comparison to the earlier versions. Though I should admit that there is still a long way to go and reach the quality of the human responses. Another thing that we looked into is, can we actually train a classifier for this task to detect the common sensibleness of the responses? We did look at a set of features and trained an MLP. In the interest of time, I'll just rush this part, but basically we were able to see that in comparison to some automated metrics, we do get higher correlation with the human annotations. And then we did some ablation between the different features that we have been using. And more details are again in the paper. Currently, we are working on releasing the crowdsourced data that we have been collecting. Hopefully, it's going to be available soon at this link. I have summarized some of the work that is ongoing right now for knowledge grounding, structured and unstructured knowledge grounding, for response generation in open domain and task-oriented conversations. It's a challenging area, but we have seen some positive results, and hoping with some of the challenges and then that we are organizing and data sets we are releasing, the future work is going to be even improving this area further. Thanks for your attention. and happy to answer any questions if any time is left.